My name is Matt Jacobson. I'm a product manager here for publisher integrations at AppNexus, and this afternoon I want to talk to you a little bit about header bidding. So first, we'll start by talking a little bit about header bidding in 2016. What were some of the key trends and themes that we saw last year? And we'll take this and we'll look a little bit about what have we seen so far in 2017, and what do we think we can expect to see for the rest of the year. We'll sort of distill that all down then into a generalized set of best practices or a code of conduct that we think all wrappers should be following. And then we'll talk a little bit about Prebid.js, our open source implementation of a header bidding wrapper. We'll talk about some of the ways that these principles are guiding the design of PreBidJS, and then we'll talk about some of the current and future areas of focus and investment in PreBidJS. So before we get into talking about header bidding in 2016, I just want to do a quick poll, just a quick show of hands from the audience. How many of you were using header bidding in 2016? All right. And how many of your businesses were in some way impacted by header bidding in 2016? All right, great. Well, just by taking a quick look around the room here, I think we're fairly safe in saying that in many ways, 2016 was the year of header bidding. It was a year in which we saw thousands of publishers implementing header bidding solutions across tens of thousands of websites. It was a year in which we saw countless stories and case studies being published suggesting 10, 20, 30% revenue increases for publishers implementing header bidding solutions. And generally, there was, in 2016, a rapid explosion in header bidding's popularity. And that really forces us to focus then and reflect on, well, why? Why did header bidding get so popular in 2016? And in many ways, it's because header bidding is correcting for a series of inefficiencies in the market that really never should have existed in the first place. And to understand this, let's think a little bit about the world before header bidding. A world in which the most common framework for managing multiple exchange partners was through a waterfall. Now, this waterfall has a number of inherent inefficiencies. It's bad for your page load and user experience, it's operationally burdensome, and it fails to capitalize on impression-level bidding. So this, then, is what header bidding really offers. It offers the ability for multiple demand partners to be competing in real time on an impression-by-impression basis. So because of the widespread popularity and the widespread growth and acceptance of header bidding in 2016, what we then begin to see is a proliferation of wrapper solutions entering the market. We see all kinds of solutions popping up last year. We see open source solutions, we see closed source solutions, we see solutions that are coming with white glove services, we see solutions that are custom and proprietary to each individual publisher implementing them. And what we begin seeing in 2016 is the emergence of server-to-server header bidding solutions. So in some ways, this comes as a bit of a way for wrappers in this cluttered solution space to differentiate themselves from one another. But really what this speaks to is increased emphasis on wrapper performance. And this is a topic that we're going to touch on in more detail in a little bit. So really then in 2016, what we saw was a return back to the basics for publishers, where publishers take back control of their own yield, where publishers demand open and transparent competition in real time on an impression level basis from all of their demand partners, and publishers are refusing to accept any inherent exchange biases or non-transparent fees. And it's sort of through this lens, then, that we can start to think about, well, what have we seen so far in 2017, and what do we think we'll be seeing for the rest of the year and beyond? And the first thing that we're seeing in 2017 is a focus on fairness and transparency. Well, fairness and transparency, that sounds great. What does that really mean? Well, in the context of header bidding, what fairness really is that all of my demand partners can see the same ad slots at the same time, are configured with the same timeout settings and the same bid bucket granularity settings. And transparency, at its most fundamental level, means, well, I can actually see the code on the page. I can see what's running on the page. There's nowhere to hide for any inherent biases, any black box auction dynamics, any shady behavior. And at a higher, more abstract level, what transparency might mean is having access to an open and transparent analytics framework through which all of the different parties in the transaction chain have access to the same set of data at the same time. The next thing we're seeing in 2017 is a focus on formats, and specifically video native and mobile formats. In 2017 in the US for video, we expect that more than half of all digital advertising spend for video to go through programmatic channels. And native is another format that's experiencing very rapid growth. And in fact, in 2017 in the United States, we expect that more than half of all digital advertising spend will go through native formats. And mobile is another format that's unique due to some inherent resource constraints on mobile devices and mobile browsers. And this really forces us again to think about wrapper performance and generally think about the way that wrappers are being implemented. The next thing that we're seeing in 2017 is the buy-side response to header bidding. And this is something I'm not going to go into too much detail in because I think that the buy-side response to header bidding is really the title of an entirely different talk unto itself. But I think there are a couple key points to hit on here. So as we continue moving away from this waterfall model of managing exchange partners, what we're seeing then from the buy side is that there really is no more concept of a single demand partner or a single exchange partner that has a pole position or first look position into a given inventory source. And so what this is really driving towards in 2017 is a more direct connection, more direct access between supply and demand, which should obviously benefit the supply and demand partners, parties on that relationship. And so the last thing that we're seeing in 2017 then is, as I've said, an increased focus on wrapper performance and really in earnest the emergence and growth in popularity of server-to-server header bidding solutions. So header bidding has really always been a balancing act between including all of your different demand partners and some impact to your page latency and user experience. And so what server-to-server header bidding really offers then, or claims to offer, is the best of both worlds here, where you can include all of your different demand partners, and for each additional demand partner that you're including, there's pretty much a negligible or near zero impact to your page. So we've talked a little bit about what we saw in 2016. We've talked about what we've seen so far in 2017 and what we think we're going to continue seeing. And we've seen along the way a couple of key themes and trends that seem to be recurring all over the place. And this lets us start thinking about, well, can we sort of distill that down into some unifying, generalized set of best practices and principles? Can we sort of come up with a general code of conduct that we think that all wrappers should be following? And I think that we can. So the first thing that all wrappers should be doing is that they should be open and transparent, where there really is no place for black box auction dynamics, inherent biases, or hidden fees. We think all wrappers should be easy. They should be easy to integrate, they should be easy to customize, they should be easy to extend. We think a wrapper should be collaborative, where hundreds of sets of eyes will necessarily find and fix more bugs, encompass and represent a broader set of experiences and use cases, and generally have better ideas than some small handful of developers working on a closed source or proprietary system. We think wrappers should be agnostic, and this means there's no inherent preferencing for any demand partners, and there's no inherent reliance on an ad server. And finally, we think wrappers should be performant, and this is pretty simple. A wrapper shouldn't kill my page, a wrapper shouldn't drive users away from my page. So we've sort of distilled down what we've seen in 2016 and 2017 into a generalized code of conduct for wrappers. And the question then is, well, where does Prebid.js fit in? And I'd sort of like to take this opportunity to introduce you all to Prebid.js. And the way that we think about PreBidJS in this light is it's a free and open source implementation of the core set of principles and best practices embodied by this wrapper code of conduct. And just to give a couple of stats to put PreBidJS usage in perspective, what we're seeing at this point is over 20 billion impressions per day flowing through PreBidJS across more than 25,000 websites. PreBidJS is a community represented by over 130 unique individual contributors. And through PreBidJS, you have access to more than 60 different demand partners. And the last thing that I want to touch on is what are we currently working on in PreBidJS, and what can you expect next from PreBidJS? So for any devout followers of the open source project out there, you'll note that a couple months ago, PreBidJS launched initial support for video in-stream formats. So what we're working on now then is extending this in-stream support to Prebid outstream video support. And as we're thinking about how we're going to design support for outstream video formats, we're really asking ourselves, well, fundamentally, what do I actually need to run an outstream video on my page? I need a slot on the page, I need a video ad, and I need a way to render that video ad. So what then will Prebid.js be doing here? So you'll tell us where on the page you want this video to render. We'll go out to your demand partners, we'll get you some video ads, and then we'll render those video ads on your page for you. And this rendering behavior can be specified in a number of different places. It can either be specified by the publisher, it can be returned by the demand partner, or if neither the publisher nor the demand partner have a way to render this creative, Prebid will provide one by default. And the other thing that we're working on right now is initial support for native formats in Prebid. So again, as we're thinking about how to design Prebid support for native, we asked ourselves, fundamentally, what do we actually need to run a native ad on the page? And we need a slot on the page. We need some collection of native required assets. And we need a way to render those assets on the page, usually through some combination of HTML, JavaScript, and CSS. So what then does Prebid do here? Again, you'll tell Prebid where on the page you want this native to render. Prebid will go out to your demand partners, will retrieve this set of required native assets, and will make sure that those native assets are rendered on your page. And either Prebid will do this rendering itself, or Prebid will bundle these assets up, send them off to an ad server, and allow the ad server to render them on your behalf. And so at this point, I'd like to welcome to the stage Matt Kendall, the tech lead on PreBidJS, to talk a little bit about how these principles are guiding Prebid design and what you can expect from Prebid in the future.
Thanks, Matt. My name is Matt Kendall. I'm an engineering manager here at AppNexus. Fun fact for you, there's actually 3 Matts on the team that work on PreBidJS here at AppNexus. So if you ever forget a name, Matt's a pretty good choice. In fact, since this is optimized, I did the math for you. The statistical probability of that is 50%. So Matt Jacobson talked about the design principles and a wrapper code of conduct. And really, that is what drove the Prebid design principles that we have for the wrapper today. And those are the things I'm going to be talking about. The first point is that it is open source. And that might seem pretty obvious in this context, but it's pretty important for us because that lets you actually inspect the code and see that we're doing the things that we're saying. We're open. There's no bid biasing going on, for example, and it's easy to use and it's collaborative. The second thing that we do is we embrace a modular architecture. And the reason we do this is so we can reduce the payload side of the PreBidJS library, and I'm going to talk a little bit more about that later on in the presentation. Minimizing latency. This is a big thing for publishers. When you add code to your page, the first thing you want to do is this going to slow down my page. Like, we shouldn't be a synchronous call on the page. We should be asynchronous. There's not blocking, and there's no single point of failure. So that's very important. Performant and functional code. PreBidJS, we've done a few things to optimize JavaScript parse time. So that's very important to us, and I'll talk about that a little bit later. Runs everywhere. We have a library that has automation and testing, and so I'll talk about that with our automation pipeline. We have some hooks into GitHub, which is very cool stuff for us. It helps both the contributor and for us maintaining the project. And finally, one thing that we do is, as a wrapper or a third-party framework on a publisher's page, we try to be a good console log citizen. So what does that mean? We're not clobbering up the debug log when you open your console and you're working on your site. We want to make sure we're cognizant of that when we're running on a third-party web page. So you guys want to see some code? Yeah, this is optimized, right? What would be optimized talk without some code? So here we have the algorithm for how we pick a winning bid in PreBidJS. So the first thing you might notice here is this Prebid global, and that's actually a macro which we replace at build time. Its default is PBJS, but you could call it peanut butter jelly sandwich if you wanted to, not a problem. That'll be automatically inserted when you do the build process. And that's simply because this is in the global namespace and we want to make sure there's no conflicts. On that, we have a bid received array, which self-explanatory holds the data structure for the bids received. Then what we do is we filter on the add unit code. Everything happens in PreBidJS on an add unit level, so we want to make sure that the bid that we're inspecting or the bids that we're inspecting are for the correct add unit. And then finally, we do a reduce function. This is a get highest CPM, which is essentially an array sort based on CPM. And then this structure here holds a default bid because you can't reduce to 0. So in case we didn't have a bid, we would just grab this 0 CPM here. So that is it. That's how we pick the winning bid. And at this point, maybe you're thinking, okay, that's not really that interesting. Okay, well, yeah, that's actually kind of the point. It's just an array sort, right? But the reason that we show you this is because we're showing you that this is open source, this is transparent, and there's no funny business going on here. So I think we can say that we are unbiased auction mechanics. Check. So diving into a modular architecture. So again, I said the reason why we wanted to do modular architecture from the beginning was to make it easier to optimize the code. As it turns out, the best way to optimize code is just to remove it. Of course, you can't remove all your code. That will cause a problem. It wouldn't work. But what we saw is publishers typically integrated between 6 and 7 different SSP adapters. And that is the code that connects to an SSP to request a bid. So we thought, okay, if they're only using 6 out of 60 plus demand partners, then we can easily drop the ones that they're not using. So that's what we did. You can pick the adapters that you wish to use, and then we will remove the code for the ones that you're not interested in. You can build this directly from terminal, or you can build it on Prebid.org. We have a utility. You can go and select which demand partners that you're interested in using, and we will email you that bundle. What we saw on average was that the bundle size was reduced by 63%, so that's a pretty good improvement for optimizing the bundle. And finally, we realized this is a very extendable pattern. It's something we can look for in the future when we want to do feature toggles, something that the publisher might not be interested in. They can drop that piece of the code, and that will make it even more efficient for them to implement. So I'm going to talk a little bit about performant JavaScript. One of the things that you think about when you're running JavaScript is the latency cost for requesting the network cost, right? But when we move to a modular architecture, we realize that's not the only cost of running JavaScript. The browser actually has to parse it and prepare it to run, and that actually consumes about 25% or more of the total time that the browser spends evaluating that resource. So what you see here is a graph of modules that a package that would have 1,000 modules, and we're not talking about NPM modules here, we're talking about the individual files that make up an individual library. So it's very common for some packages to have 1,000 modules. So these are the different tools that you could use to bundle those modules up and produce a binary, such as Browserify, Webpack, Rollup. And you have here on the left the load time in milliseconds, and then on the right, this is the parse time. So we're looking at the evaluating who's doing a better job at rolling all these up and then having the browser parse them. So this is an expensive process, and some browsers are better at it than others. There are some smart browsers out there, and what they do is they actually do a pre-parse. So that's looking at the script that's on the page, and they're evaluating it with quickly to see if the syntax is valid, but they're not actually doing a full parse. So they use a heuristic to determine this, and sometimes they get it wrong in a package such as PreBidJS, where we're highly optimized, all the code's going to be used. So we actually want to tell the browser that, so they don't do a pre-parse and then a full parse. We just want them to do a full parse. So there's a way we can do that. We used a library called Optimize.js. This is included in the build process of Prebid, and what it does is it wraps functions in parentheses, so it'll basically tell the browser, hey, go ahead and execute this now, parse it now, because you're going to need to. And what we saw was a reduction of about 22% in the time it took to parse that given resource. So I think the browsers are going to get smarter and better at this, but for now, this is a great optimization that you can do to parse JavaScript and reduce that time. Okay, so now I'm going to talk a little bit about video and video demand in PreBidJS. As Mac Jacobson said, we released in-stream video support, and there's some things that we did to optimize that specifically with PreBidJS. So you might see this a lot on the web today. You know, video is buffering, and that's not a great user experience. There's some things with video that are inherently better for us to do optimization with, and one of that is running the auction away from the play button. So all this really means is we're running the auction as soon as the page loads, as opposed to waiting for the user to click the play button. So we can do that while the rest of the page is loading, have an auction, and then once we receive demand, we'll cache it in the PreBidJS memory storage for under that bid ID, and then we'll wait for the user to click the play button, at which point we'll synchronize the video playback with the fetch demand that we have, and they'll see an instantly loading pre-roll ads such as this. So we've integrated with a lot of the major video players. If you go onto prebid.org and look at our blog post there, we have information on how you can get started with different video players, and we wrote all the integration code for you. It's all open source. You can take a look, and it works seamlessly with PreBidJS today. So talk a little bit about some automation that we did, and so I'm going to dive into that a little bit more here. One thing that we have to do with this project is we review GitHub PR requests or pull requests that we receive from different contributors, SSPs, partners, etc. One of the things that we like to do is enforce code quality standards and make sure that the code that comes into our project isn't breaking anything. So we implemented integration onto Travis CI. So what this does is it runs about 800 unit tests at time of GitHub pull request submission. So this is really great for not only the maintainers of the project, us, but also for the contributors and SSPs, because they get instant feedback on whether the code that they submitted is going to work correctly, if it's going to pass the build quality standards, and et cetera. So it's really great. It's built on top of Travis CI, which has an integration directly into the GitHub. Underneath, we're running Nightwatch for our test runner. Selenium WebDriver does the assertions, and then everything is run in BrowserStack, which is a service that provides different platforms for testing in different environments. We give it a list of configured browsers to run in, and then it'll run it and tell us if all the tests pass. So this is really great for the maintainers and for the contributors. Okay, I'm going to talk next about what we're working on ahead of the next phase of the project, which is Prebid 1.0, and also server-to-server header bidding and how that fits in with PreBidJS. So up until this point, we've been a pre-1.0 project, and we've done that for a number of reasons. One was to make it easier for people to contribute code, and we've been a little bit intentionally lax on the different code that they can contribute to make their adapters work. So the first thing what we did was we opened an intent to implement to say we want to tighten some of the code quality standards and tighten some of the things that performance standards that we have in the project. So we got community feedback on a couple of ideas that we had discussed, and so it really was a community-driven effort to try to move to 1.0. So the first thing that we realized with some adapters were including bundled JavaScript libraries. So this creates an additional hop, and also it exposes a little potential of data leakage risk when there's JavaScript that we're not vetting running on the publisher page. So publishers are pretty concerned about this. So the first thing we decided was that there will be no bundled JavaScript library included in the adapter with the Prebid 1.0. Also, that decreases the latency because we don't have that extra hop for getting the library. The next thing we decided to do was have Prebid handle the pixel dropping and add-ons that adapters might be interested in doing. So basically, this is important so that process stays out of the critical path or the ad rendering path, so that happens as quickly as possible, and then the Prebid library will handle it as it sees fit when the resources for it are available. So we kind of manage that process a little bit better. We're strongly encouraging a single fetch mode. What that means is a single HTTP request will be made for multiple ad units on the page, and that is something that will also decrease latency. And then finally, video and native, which we talked about, will be directly built into the framework, so they will be just first-class citizens along with in banner and all the other types that we support today. That'll be right built into the framework. So now I'm going to talk a little bit about server-to-server. Everything we've talked about so far has been client-side header bidding, and now we're going to talk about S2S header bidding. So server-to-server header bidding works a little bit differently. It moves your demand partners off into the server or into the cloud instead of running on the client. So one reason you might want to do that if you want to scale up the number of bidders that you have in your wrapper with the inherent limitations of the browser and how many concurrent connections you have, you're limited to the number of SSPs that you have running in your wrapper. So the way this works is very similar to client-side. You have, in the first step, you have your wrapper configured to contact the server-to-server endpoint, at which point the server will then concurrently call all your configured SSPs, and it will hold an auction and return to you the bid, the winning bid, at which point the wrapper would then render the ad directly on the page or pass it on to the final ad server for decisioning. Some of the challenges you might see with server-to-server are lower cookie match rates, and also you would have to rely on the server-to-server endpoint in terms of the auction mechanics that are going on. So how does PreBidJS fit into this server-to-server model? Well, as it turns out, we can actually do what is called a hybrid model, where we actually send both client-side and server-side requests at the same time. So we're looking to build support into PreBidJS, which will allow you to take your existing configuration that you have on the client and then change it to automatically switch some of those to the server side. One reason you might want to do that, again, would be to scale up or to potentially move some of your high latency partners that you're working with into the server and then keep your high-performing cookie match rate on the client side. So you can do a nice hybrid approach there. So how this works, again, is the wrapper or prebid on page calls the S2S endpoint at the same time as it's calling the demand partners that are configured to be called client side, and that happens simultaneously, and they would both return their top bid, and there would be a final auction in PreBidJS wrapper to compete, and then the final bid would then again be either rendered directly on the page or it would be sent on to the final ad server for decisioning. So I would like to take this opportunity to officially invite you to join our community for PreBidJS to make PreBidJS a much better project than it is today. And we, like I said before, we are community. It's a community-driven project. We very much would like your support. And we love pull requests for sure. So if you have any ideas for making PreBidJS better, we welcome them. At the same time, we have some information up on this page for if you're a publisher, if you're looking to get PreBidJS configured on your site. We have a couple of great guides for you on Prebid.org. And also, if you're an SSP or a bidder and you would like to get your adapter added to the project, we have a guide how to add your own adapter, which is a great resource to check out as well. Thank you very much. And we're going to have a quick Q&A.